So the last part of section 3.1 gets into the mean of larger groups of numbers. So, and when there's a lot of repetition as well. So let's take a look at this one, and it kind of will build into the process a little bit for us. So we want to find the mean of these numbers. Now it's not a very big list, so we could just plug them into our calculator one at a time and just say, okay, 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 3 and so on. But that seems a little silly. What if there had been 100 ones that we had to add up and 52s and stuff like that? Would we want to add them up one at a time in our calculator? No, of course not. So what we want to do instead is batch our numbers when there's a lot of repetition. So in this case here, if we wanted to find the mean, we could say, okay, I'm going to take all of those ones and batch them. I'm going to say 1 times 4. That takes care of the ones. And then I'm going to take care of the 2's the same way. I got the 2's, and then I'm going to multiply that times 3, because there's 3 of them. And do the same thing with the 3's, and with the 4's, and with the 5's. And even though there's only 1 6, I'm going to do the same thing with the 6's as well. I'm going to multiply it times 1. So, what should I do with all of those products though? I'm not going to just kind of leave them floating. I'm going to want to add those all together. Because remember, I still need to try to find the sum of all of my numbers. So I multiply just to make it easier, but then I have to add everything to get that total. Now, what do I divide by? Is there a shortcut for that? Well, you probably can guess yes. Instead of just counting one at a time, let's look at the batching that we did. There was 4 ones, so I'm going to pull the 4 down and add that to the number of 2's, and then add that to the number of 3's, and the number of 4's, and the number of 5's, and the number of 6's. So there's where that 1 is important. Even though it doesn't help us multiply or anything up here, we need to know about it for the number of values. So this is what we're actually going to want to do calculation-wise. So if we add, or if we multiply and add all of those up, I believe, excuse me, we get 48. And if we add up the bottom, I believe we get 16. So that gives us a value of 3. And we can kind of see that 3 does look like the middle of that set of data. So we're good. But now let's formalize the process. We don't want to write it all wonky like that. Let's take a look at the formula. So this is called the weighted mean. So similar to the mean of a list of data values, this process utilizes the data values x and their respective frequencies w. Why they use w, I don't know. But we're going to be seeing a slight variation where instead of w, they're going to use f for frequency. So we'll see that in a second. So in this sense, we have the following. So we have the sum of the product of the frequency times the value. So that's exactly what we did up above. And then we added up all of the frequencies, and that's what we divided by. So note, this calculation does yield the mean as it utilizes all of the data. So let's try it out on a little bit different problem. So we got our values. So this is kind of like our x, and this is our frequency. So that's like our w or f. I'm going to start using f. I don't know why they use w, but they just do for weight. But now we need our products. So all we're going to do is take care of all of these 25s in one calculation by multiplying. So we can multiply to get 100. We can multiply this and get 196. We get 300. We get 93. And we get 480. So you can multiply across pretty quickly Because otherwise, if we wanted to rewrite this entire table, we'd have to say, okay, well, I have a 25 and a 25 and a 25 and another 25. So there's my 4 25s. Now I got to write out 7 28s. So 28 and 28 and so on. And I don't think anybody wants to do that. I don't. So, okay. So we've taken care of all of the adding of those individual repetitions in one calculation. But now, what do we do with those products? Right, we have to add them all up. So I'm going to use a calculator just to be safe. So 100 plus 196 plus 300 plus 93 plus 480. So 1169. So 1169, I'm going to write it down right under here. So there's the total of all of our data values. Now we need to look at our frequencies. So if we add this up, what do we get? So we get 10, 20, 35, 39. So 39. And so now the last step is to divide. So 29.97. So the mean is equal to 1169 divided by 39. 29.97. Now, technically, we would round this to how many decimal places? We would round it to 1. But we can see if we rounded it to 1, that's going to bump it up to 30. So, in this case, 30 is the answer. So, and just to compare it back to our table, does this look like the middle? And the answer is yes, because if we look at our values, the smallest one is 25, the largest one is 32. 30 is in the middle just on this table, but if we looked at all the data values, 30 is still going to be in the middle. So we're probably correct. Now, looking at the question at the bottom, so how would you rather find the mean, by adding numbers one at a time or by multiplying and adding? Hopefully you're saying multiplying and adding. All right, so let's take a look at a couple more problems. So this next one is an application of the weighted mean, and it's finding GPAs. So this is how they do it at the college. So if you're trying to find your GPA, this is what they do. So the first thing we know is that the student has grades of B, C, B, A, and D. And those courses had corresponding numbers of credit hours of 3, 3, 4, 4, and 1. The grading system assigns quality points to letter grades as follows. A is a 4.0, 3.0 for a B, C is a 2.0, D is a 1.0, and F is a 0. Compute the grade point average and round the result to 3 decimal places. That's typically what GPAs are rounded to. So if the Dean's List requires a GPA of 3.000 or greater, did the student make the Dean's List? All right. So I'm going to put the grades in the first column. So we got a B, we got a C, a B, an A, and a D. And then I'm going to put the credits here. So 3, 3, 4, 4, and 1. Now, the grades, obviously we can't work with letters. So first thing we should do is change those to numbers. So B is a 3. So this is a 3, 2, 3, 4, and a 1. So now we have numerical data. So what do we do next? If this is weighted mean, we got to fill in this next column, which is our products. So if we multiply across, we got 9, 6, 12, 16, and 1. All right, now getting a little bit of a glare, but now what do we do? Hopefully you're saying we're going to add. So we want to add up all these numbers here. So what do we got? 22, 34, 54, no, 40. Let's just do it on the calculator. I'm not going to make a mistake. Hopefully not. 44. All right. I would have got there, but So 44 is our sum. And now we got to get our credits. So we got 10 and 15. So now, why did I add up the credits? Why didn't I add up the grades? That's a common question. The credits, remember, is kind of like the weight of the class. So if you get a grade of a 3.0 in a class, it has a weight associated to it based on the number of credits. If it's a 4-credit class, it's going to be worth more than a 1-credit class. So the credits are like the frequencies. So that's why I added those up. So now your GPA is equal to 44 over 15. So we can just divide that by 15. Oh, darn. So the GPA is 2.933. So, did the student make the dean's list? Nope. Nope, didn't happen. Close, but not quite there. So, all right. Now, the last problem, which I'm going to squeak into this video, is the mean of a frequency distribution. So very, very similar to our weighted mean process. We're still going to be multiplying our frequencies times our values, and then we got to add those up, and then we want to add up the frequencies, and that's what we're going to divide by. The problem is in a frequency distribution like this, where we have classes, we don't have a specific value. We don't have a value for x, but we can create one. And the best point to pick in this interval is going to be the midpoint. So midpoints are going to be your de facto x's for these formulas. So once you've found the x's, then it's exactly the same process as it was for weighted mean. So we can find those pretty quick. 11.5, and then we can use our class width, which hopefully you see is 4. So 15.5, 19.5, 23.5, and 27.5. So now we have those x's. Again, we don't know exactly what values we have because it's a frequency distribution. So we just have these frequencies, but we don't know what 15 numbers are in this class. So that's why we're estimating. We're estimating with 19.5. So now if we multiply across, and I'll do the other ones on my calculator just to be safe. So 19.5 times 15 equals 292.5. And then the last one, 23.5 times 7, 164.5. All right. So now we have our products completed. So what's the next step? You got it. We got to add those up. So if we add those up, I already got the 164 in there. So let me add in the 55 and the 292.5. and the 11.5. So 523.5. And so now we can add up our midpoints. No, we don't add up the midpoints. So the midpoints are garbage. We don't need to add our x's up. A little quick rule of thumb, only add up columns that have an f in them. So products is really a product of x times f or f times x, either way you put it. If you want to match the formula, we'll just write it the other way around. F times x. Midpoints are like your x's and the frequencies are your f's. So only add up the columns with f. Those are the ones you need. And we got 25 here. So now our mean should be equal to 523.5 divided by 25. So if we divide by 25, we get 20.94. Yeah, weak lead. So 20.94. Now, a common mistake people make is they want to divide by 5. There's 5 classes, so let's divide it by 5. But if you divide it by 5, you're going to get a much bigger number. you're going to get something like 105 almost. So that is definitely not going to be the mean, 105, because it's way too big compared to your data. So be careful. You always want to divide by the total of the frequencies. That will give you your mean. And now, same thing as before, we should round this. There's no decimal points here. So we should round it to 1. And don't forget your units. So 20.9 milligrams. All right, so that wraps up this video, and we'll see you in the next one.